So, Chris, this is great to be back here together again for another season of Manure Mondays. And I was just thinking, we did Manure Expo. When was that? 2021 we hosted here, Listowel, Ontario.
That's right. That's right, Andrew.
That's hard to believe. That seems like a long time ago, but there's been a lot of manure under the bridge, shall we say, between from then till now. But and I am wearing my Manure Expo 2022 shirt today.
Oh, you're better than me. I didn't even think of that. Oh, those are a lot of fun. If anybody, if you should turn around and let people see the back.
Can you read that?
Maybe if I make you big. Rated M for manure, the allure of manure. Manure happens, we make the most of it. The world's biggest gathering of turd nerds. Manure haulers spreading the wealth. If you're squeamish about poo, this t-shirt's not for you. We've always been socially distant. Yeah, those are pretty cool.
Yeah, they always do a good job of their slogans.
T-shirts. Yeah,
for sure. And now you yourself, Chris, you were able to attend last year, weren't you?
Yeah, it was in Pennsylvania. And just to plug out for this coming year, it is July I think it's the 9th and the 10th in Wisconsin, not too far from Madison. So if you don't have connections, Google it, mark the date in the calendar because it's always a good event.
Absolutely. And so while we're talking about that, let's just remind folks in some of the history. So yes, we hosted Manure Expo. It was originally supposed to be 2020. Of course, during the pandemic, we postponed for a year and then we went virtual. So we were able to offer the event. But Manure Mondays followed after that. Give us some of the background of how that came about and what we did last year, Chris.
Yeah, so for the Manure Expo, the actual events where people meet, they have concurrent sessions, so a little bit similar to the Ag Conference. And so we had all ready to go for 2021. We had a whole bunch of concurrent sessions planned, but then when the event went virtual, we only had the capacity to do maybe about a quarter of them. And so that was where we thought, well, gee, we've got a lot of good speakers, we've got a lot of good topics. How do you pick which topics are more or less important? And so that's where we thought, hey, we have the opportunity to do a webinar series. People, there's a lot of people in Ontario, in Canada, in the United States where the problems are similar. These kind of webinars, we have the ability to draw from experts all over the North America. And so we thought, hey, here's a way that we can extend the information, share ideas on a larger term. And that's kind of how it started. And then last year we kind of took on more than we could, or a lot anyway. And we decided this year maybe we wouldn't do quite as many as last year. So this year we're doing a series of 6 or maybe 7. And just for those of you that saw the posters, we did have to make a slight change to the poster. We had one on biosecurity scheduled for February the 13th. That one is postponed to March the 13th. And so instead we have one on weed seeds and manure. And then the 10 questions, that one was going to take a little bit of work. So we're deciding whether we'll do that at the end or save that one for next year, just to keep everybody interested, I guess.
Right on. So now that we're after 2 o'clock, I will do a formal welcome. My name is Andrew Barry. I'm with OMAFRA, and I am based in Ontario, Canada. And we welcome you for joining us today. I know we've got folks from Ontario, we've got folks from across the border and maybe beyond that as well. But we're thrilled to be back at it here for another year of some great discussions around manure management. And I was just chatting with Christine Brown, my colleague, and many of you know Chris, who really is the driver behind this. Chris is known in Ontario as the Manure Queen. And that's because if there's something that's happening that has to do with manure, she's a part of it and is probably right back into the nitty-gritty of it, and has worked for many years in this industry and tremendously respected here in Ontario, across Canada, and across the border as well. So we're glad to have Christine back doing this again. you see with me here, my colleague, James Dick. James is going to be speaking today, and his topic, the first topic of our series, is impact of management decisions on greenhouse gas emissions. So I'll let him start in a few minutes, but just as we get going, just some quick logistics, a reminder, questions are welcome. And James has said he'll take questions throughout the presentation as well. He'll try and keep an eye on the chat. Questions are through the chat, so post them there as you go. And in fact, just to get you warmed up, I would love to hear where you're coming from today, and is winter there with you? We sure haven't had much winter so far, James, but it looks like it is starting to come. You know, as I introduce James here, James is working down in the Niagara Peninsula, and often you don't get crazy winters the same way we do up in Bruce County where I am. But I think this year you've been getting it worse than I have down there. A few good storms. So we're sharing the love all around this year. It's wonderful. So just some quick reminders that a couple things. This session has been awarded 1 CEU credit, and that's for nutrient management. And so we don't have a QR code for today. What we'll ask you to do at the end is just post your name and your CEU code in a direct message right to Christine Brown in the chat. And then we'll be sure to get that recorded for you. It also, this is a KSE event as well for nutrient management. And so we'll provide a QR code at the end of James' presentation where you can get credit for that here in Ontario, the KSE program. If you don't know what that is, then it doesn't apply to you, and don't worry about it. So yeah, let's get rolling here. We do record these. They are posted later on OMAFRA Field Crop News. That link will be sent out to you, so you don't have to write anything down. You'll get a follow-up email. But excited to get back at this, get into this presentation with James. And so James is a direct colleague of mine. He is an engineer. He's a crop systems and environment engineer based out of Niagara Peninsula. And I think I'm just going to turn it right over to you, James.
Thanks, Andrew. It's a pleasure to be here this afternoon. Yeah, as Andrew said, my name's James Zick. I'm the engineering specialist for crop systems and environment with the Ministry of Agriculture, Food and Rural Affairs here in Ontario. And to kick off Manure Mondays and get rolling, we're not starting light. We're starting with a pretty heavy topic, the impact of management decisions, particularly from manure on greenhouse gas emissions. So we're going to talk a bit about greenhouse gas emissions, especially as they relate to livestock production systems and manure. We're going to look at Ontario's emissions profile and how ag fits into that, really from an awareness perspective. And then I'm going to talk a bit about some tools that we have here in Ontario, and particularly a new one that we've just launched, an online tool. It's part of our AgriSuite platform, and it's focused on helping farmers like yourselves understand what do greenhouse gas emissions look like in the agricultural sector, what do they mean for you, and more importantly, what practices can you implement on your farms to help to manage and mitigate those emissions. So I'm noticing in the chat, it's great to see where people are coming from. Lots of people from Ontario, but lots of people from outside of Ontario as well, which is great. Great to see the reach we have. I will say, this presentation is focused somewhat on Ontario, especially the tools that we've built. Obviously, being a provincial ministry here, we are focused on our province, but that's not to say that the learnings aren't applicable elsewhere as well. So I hope that no matter where you're calling from this morning or this afternoon, rather, that you find this interesting and insightful. So let's get going. One of the things I love to do at the start of these kind of talks is show this image. And I really like to show this image because it shows, when we're talking about greenhouse gas emissions, it shows just how complex everything is and the different gases that are present that come from our natural environment, and the different ways the greenhouse gases move around in our environment. We all know that growing plants, generally they uptake carbon dioxide. I mean, we learned that way back in elementary school, plants. I remember learning that plants breathe in carbon dioxide and they exhale oxygen, kind of a nice proxy for, or rather the opposite of what we do, right? We breathe in oxygen we breathe out, carbon dioxide, plants do the opposite. So, that's the simple version, but obviously it's a lot more complicated than that. And you get into, so you grow biomass, it takes up carbon from the soil and from the atmosphere, but then that biomass gets harvested and it decomposes and those emissions are released. When we're applying fertilizers or manures, this is Manure Monday after all, that's putting a lot of nitrogen into our soil, which is great. We want that to grow our crops, but unfortunately some of that nitrogen escapes back into the atmosphere as nitrous oxide. Methane is also a big greenhouse gas when it comes to agriculture, both from enteric fermentation, from manure storage, from other sources as well. Rice and anaerobic digestion of things produces a lot of methane. So there's a lot of different relationships here, and carbon moves around a lot, and that's okay. Carbon is supposed to move around a lot. The challenge comes really when we're taking a source of carbon that hasn't moved for a long time, like oil in the ground, and we're using that and essentially putting that into our atmosphere. So, that's one of the things we're trying to manage here. And we're going to talk a little bit more about what this looks like more specifically from a livestock perspective. But I wanted to talk just briefly about the different greenhouse gases. As you saw in the previous picture, there's a lot of them, or there can be. And a greenhouse gas essentially is any gas in the atmosphere that absorbs heat, it holds that heat, and it releases that heat to warm the atmosphere. Without greenhouse gases at all, our Earth would be a cold, hard rock, just like the moon. So we do want greenhouse gases, but
after this is over, we can go out.
But we have to manage that. And I will just remind folks listening, if you could please make sure your microphones are muted, that would be appreciated. I'm just hearing a little bit of background noise. But moving on, I just wanted to say that when we talk about emissions, you probably hear a lot of people talking about tons of emissions, tons of carbon dioxide. You don't hear as much about some of the other ones. And the reason for that is when we talk about emissions, we equate everything to carbon dioxide so that we're all talking the same language. And we do that by looking at what's known as the global warming potential, or in other words, how much energy does a certain tonnage of gas absorb compared to the same amount of energy in carbon dioxide. So carbon dioxide by definition is always one. It's one global warming potential because it's the reference point. The other two primary greenhouse gases from an agriculture perspective are methane and nitrous oxide. Methane comes a lot from livestock, from enteric fermentation and manure. And methane is about 28 times as potent as carbon dioxide. So in other words, it takes 28 tons of CO2 to absorb the same amount of energy as just 1 ton of methane can. And that's pretty potent. Nitrous oxide, which is the one that comes from primarily fertilizer use and soils, is even more potent. So 1 ton of nitrous oxide absorbs the same amount of energy as 265 tons of carbon dioxide. So you can see that a small change in nitrous oxide can have a big impact in terms of overall emissions when we look at it on a carbon dioxide equivalent scale. And this is one reason why there's been a lot of focus on nitrogen emissions more recently. For those of you in Ontario and in Canada, you're probably aware that the federal government has been a little more focused on fertilizer emissions, and this is partly why, because nitrous oxide does have a pretty substantial contribution when it's compared to the tonnage of carbon dioxide. But it's sometimes even hard to grasp what a ton of emissions or a ton of gas is because we can't see it. I mean, we know what a ton is, right? A ton is 1,000 kilos, 1,000 grams, or 1,000,000 grams, pardon me. But you can't really picture that of a gas. So for all of those that are familiar with crop farming, I'm going to throw this out to you. It's about the same volume as 400 tons of corn, roughly about 20,000 cubic feet. Or if you think about the grain bins that are on your farm, you take a grain bin that's about 30 feet in diameter, 28 feet high. If you fill that with carbon dioxide, non-pressurized carbon dioxide, that's about 1 ton worth of gas that would fill that bin. It's about 400 tons of corn you could fill the same bin with, but so gas is obviously a lot lighter. But that's kind of the picture that should be in your head when you have a volume of carbon dioxide. Probably the more useful comparison, though, is in terms of fuel that you burn. So when you burn fuel, one of the byproducts is carbon dioxide, because we're burning a hydrocarbon, so it produces CO2 and water. And so in particular, look at that line that lists diesel there. About 370 liters, or that's 100 gallons of diesel fuel, will produce you about 1 ton of carbon dioxide emissions. So think about that. Think about how often you burn through 100 gallons of diesel fuel on your farm, in your farm equipment. And that'll tell you about how long it takes you to produce a ton of carbon dioxide, from at least from the fuel consumption side. But let's circle back to livestock production. That's why we're here, and in particular manure today. So in a livestock production system, there are a number of different sources of greenhouse gas emissions, particularly methane and nitrous oxide. So we'll start with the barn. Methane and nitrous oxide are produced throughout livestock production. And when I'm showing the arrows here, you can sort of take that as a rough, like a rough scale of the size of the emissions. So in terms of the barn production, I mean, that's where you've got your livestock. So you're probably pretty similar quantities of methane and nitrous oxide in that respect. If you've got outdoor livestock housing, like a paddock, your methane's probably not as high, but your nitrous oxide is going to be a lot higher. The reason for that is you're getting, in addition to the manure being there, you're also going to be getting runoff. You're going to be getting volatilization in the outdoors. So you're going to be losing a lot more of that nitrogen content to those kinds of emissions. Of course, you can take your manure, you can scrape it into a pile. Piled up manure doesn't have a ton of methane emissions. It does still have a fair bit of nitrous oxide emissions, but it's not too bad. Of course, if you put it into a liquid storage, your nitrous oxide won't be as high, but your methane starts to get quite high when you get into an anaerobic situation. That's where the methane producing bacteria really like to get going. And so then if you even have an anaerobic lagoon, your methane is going to be even more significant. Of course, then you're going to land apply. And in land application, you don't really need to worry too much about methane. In fact, you might be beneficial from a methane perspective, but you will get nitrous oxide emissions, again, from that volatilization, from that leaching, from those soil microbes that will cycle that nitrogen. You will get some losses there. Now, again, this is a cycle. It's not that any of these things are bad, but we do need to watch the kinds of emissions that we're getting at various places. And there are practices we can do and things we can do on our farm to help reduce that. So we're going to talk about that in a little bit. But I want to take a step back now and show you the picture of this in the context of what does Ontario's overall emissions look like. And we know what Ontario's emissions are because we calculate them every year. The federal government does, and they publish them in our annual report called the Canada's National Inventory Report. And developed countries around the world, including Canada, the United States, and many others, do this on an annual basis and submit these reports to the United Nations under their Intergovernmental Panel of Climate Change Framework, or IPCC. So Ontario's emissions in 2020, which is the last year we have data for, because there's a couple of years reporting delay, they were about 150 megatons, or 150 million tons overall. And agriculture takes up about 8% of that. Most of that is from soils, livestock, and manure, and then a small portion is from stationary combustion, which is really heating and transportation. Now, you can notice that about 2/3 of Ontario's emissions are in that energy category, whether it's generation, heating, or transportation. So that's the vast bulk of our emissions in Ontario. That's where they come from. Now, if we break this down by greenhouse gas that we looked at before, we're still talking tons of CO2 here, but CO2 itself is about 83%. So the vast majority of our emissions. And from an agriculture perspective, that's mostly our fuel usage is where that fits. If we look at methane, again, this is tons of CO2, but looking at the contribution of methane, that's only about 9% of Ontario's emissions, but agriculture is about 1/3 of the methane that we produce here in Ontario. And then with nitrous oxide, it's only 5% of Ontario's total emissions, but agriculture has almost or actually more than 2/3 of that, almost 70% of the nitrous oxide emissions in Ontario are from agriculture. And finally, there's a few other greenhouse gases, mostly from industrial processes, that make up the last few percent, and we're not going to be worried about those today. But let's take a closer look at Ontario's agricultural emissions. So you can see that nitrous oxide has the biggest fraction, methane close behind, and CO2 is in third place. If we break that down a little further, we've got mostly soils as a contribution from nitrous oxide. We've got livestock is pretty much the main contribution from methane, both enteric and manure. And then we've got CO2, which is mostly the fuel usage, transportation, heating, and then a little bit of other stuff. And I see there's a question in the chat. So how does the government ground truth their calculations of emissions based on the variability of environmental conditions? That's a really great question. The published reports that the government publishes every year, they go into a lot of detail on the calculation of how they do this. So it's still a modeling approach. In a lot of cases, they're using emissions factors that are corrected for climate, that are corrected for local soils and weather conditions as best they can. But it still is an estimation approach because, of course, it's virtually impossible to actually measure the emissions from things like agricultural soils, things like animals. I mean, we're not putting greenhouse gas probes on the back of every cow and pig and sheep in the province or the country. So a lot of it is modeled based on the best available science, based on the best available knowledge about local climate and things like that. Where possible, they take measurements. Things like fuels, for example, are a lot easier to measure because we know about how much fuel gets sold every year in the province. We know about how much fertilizer gets sold every year. So we can access some of that data through statistics, but it's definitely a combination of measuring and modeling. So I hope that addresses your question there in the chat. And if not, you can certainly follow up with me afterwards. My contact information will be at the end if you want to have a more detailed discussion. But I also wanted to show you how we compare to 2005. So on the left is 2020, and then I've added 2005. And what you'll notice is that we're about 8% higher in our emissions than we were in 2005, at least from an agricultural perspective. The other thing you'll notice is that our soils emissions were a lot lower and our manure and enteric emissions were higher. So obviously, the last 15 years, we've used a bit more fertilizer and we don't have as many livestock. But I'm also showing you 2005 because that's the year that our federal government is using for their targets. They're comparing everything to 2005, and they've set some future focused targets. The first target they've set is by 2030, they want to have our provincial and national emissions being 40% lower than 2005 levels. And so since we're up 8% already, we actually have to drop about 50% to hit that target by 2030. And we're already 3 years into the 2020 decade. So we've obviously made progress maybe in the last 2 years or not. And because there's a delay in reporting, we'll find out in April of this year what 2021's numbers were like. But then by 2050, the government set an additional target of being net zero. Now, that doesn't mean zero emissions, but it does mean that if we're producing emissions, we need to be offsetting those emissions with carbon sequestration, such as planting trees or some other practice that is offsetting the emissions that we are producing. Obviously, it's impossible to produce zero emissions from things like livestock productions, but we'll do our best. I see a question in the chat, how much greenhouse gases are produced by an average 25-foot tree? That's a good question, and I'll touch on that a bit later. So hold on to that question and remind me of it later if I don't get there. But I do want to talk right now about how we can get maybe to those targets. So by 2030, realistically right now, if we're starting from the 2020 numbers, that means we have to be almost 6 megatons fewer emissions from agriculture anyway by 2030. And it's important to note that these targets apply across all sectors, across all business areas. So it's not like this is focused on agriculture. This 40% target is across the entire country, and every industry in theory needs to be contributing to this. Now, some industries will probably do somewhat better than others. And so overall, we still need to try and hit that target. but that's where we're headed. The good news is there's a study done in 2021 that looked at a bunch of natural environment type solutions across agriculture and forestry and wetlands and all that kind of stuff. So I've pulled out some of the agricultural practices here, the BMPs, and highlighted kind of what their top end estimates were for the potential reductions. Now, this doesn't factor in costs here. They did look at costs in the study. I'm just trying to show what the potential is. You can see manure fits in there. They're talking mostly about acidification, which I will touch on later. But the important thing to note is that, you know, from this paper anyway, they've shown that it is in theory possible for us to achieve that target of reduction by 2030. And then by 2050, we got to basically double that reduction. And if we've planted enough trees by 2030, then the continued growth of those trees and sequestration of carbon should get us more than above that target by 2050. Because obviously as trees grow, they sequester more carbon. So there's a question in the chat about how existing carbon sequestration in agriculture and forestry is accounted for. I'm not accounting for that here in the agriculture section. The forestry section is treated differently, and it is accounted for separately in the National Inventory Report. So I don't have details on that right now, but if you're interested, you can follow up with me afterwards and we can talk about it. But I will say that it's also important to note from Canada's perspective, because I've heard this argument before too. I mean, Canada has significant natural resources, significant forest resources in particular. So overall, perhaps on a national scale, if you look at that forestry, we as a country may be close to or even net negative in terms of our emissions. However, it's important to note that not every country will have the ability to do that. There's obviously lots of countries that don't have the natural resources that Canada has, and greenhouse gas emissions don't stop at country borders. So although, yeah, we do have a lot of natural resources here in Canada and in the United States as well, it's something that we have to manage very, very carefully and recognize that the benefits of those don't apply only to us, and they apply across the globe. Increasing, so there's another question about biofuels. Yeah, there's lots of work being done on biofuels. There's a lot of potential there. I'm not really going to touch too much on that, but I will say if you want to learn about that, you should sign up for the Innovative Farmers of Ontario conference, because there is going to be a session talking about biofuels and alternatives like hydrogen, especially for the agricultural sector. I don't want to get too derailed from the manure conversation here. But it is a really important question, because it is one way that we can start to offset some of the fossil fuels that we use for transportation and heating. But I want to move now and say, okay, we've talked at a high level, you know, provincial or national scale, and what does that mean for the average farm? Well, that's why we have this tool set called AgriSuite. And for those that maybe aren't from Ontario, or those that haven't worked with AgriSuite before, AgriSuite is an online platform. It used to be a computer desktop application. We've rebuilt it in the last few years. It's now cloud-based. It's online. It's free to use. It's available on your phone, your tablet, your computer, basically anything with an internet connection and a browser. It's available in both English and French, in metric, imperial, or US units. And we've got a whole host of tools here that can help you as farmers make better decisions in terms of managing your farm, in terms of making better decisions, especially when it comes to the combination of environmental and economic considerations. So some of the tools on here are a bit more regulatory, and this is a livestock group. So some of you may have been involved with AgriSuite already when you've been doing nutrient management plans, when you've been doing minimum distance calculations for a new barn, perhaps. But you might not be as familiar with some of the other tools that are a bit more focused on education and awareness and decision making. So I'm just going to highlight a few, and then we'll talk about our greenhouse gas tool. For those not in Ontario, most of these tools, I mean, you can access them. They are focused on Ontario with Ontario soils data and things like that, but certainly feel free to explore and check them out. So the first one we've got is crop nutrients. This one looks at what crop are you growing in your field, what's the yield you're expecting, and it will help you understand how much nitrogen, how much phosphorus, and how much potassium is that crop going to need to grow, how much do you already have from your soil test information, and what might you be removing when you harvest that crop. The organic amendments tool will look at the same thing, and it'll look at the available nutrients that are coming from your manure or your biosolids or whatever organic amendments you're putting on. And it'll also help you understand what's the economic value of that in terms of the fertilizer value. So if you've got a source of manure or something, you can really understand what the actual dollar value is of that. The fertilizer tool will help you blend different products and get the fertilizer rate you're looking for. Phosphorus loss assessment tool, or Plato, will help you understand the risk of losing phosphorus from your fields and what practices you can adopt to help reduce that risk. And then the field management tool kind of combines all of the above tools, and you can really build the entire crop rotation for your farm, put in your nutrient applications, put in your manure applications, and you can see what your fertilizer balance is over the entirety of the crop rotation, how things like legume crops factor in and give you nitrogen credits and things like that. So certainly check that out and take a look at what your current crop system would look like. The manure storage sizing tool, pardon me, is focused on livestock farms. Obviously, you've got livestock, you need to store their poop somewhere. This is how you figure out how much you're going to have and how big a storage you need. So it will work through a whole bunch of different scenarios and help you come up with the right size and the right design for your manure tank. And then the greenhouse gas tool, which is the one we're talking about right now, is focused on estimating greenhouse gas emissions for an ag operation. So we basically take all the above tools and we add in the emissions factors, we add in the weather data and the other considerations to estimate, at least at a high level, what's your emissions look like on your farm and what can you do about them. So it's really focused on being an educational tool to help you understand the impact of greenhouse gas emissions, help you understand where the different sources of emissions are and what gases are coming from those. And also it can show you what you're doing right now on your farm that's already beneficial. So it's not just to point fingers and say, hey, you need to do this, this, and this. It can also show you where you're already making a difference and doing better than if you weren't doing some practices. And I'll show you that in just a few minutes. But yeah, really the intent of the tool is that we're hoping that all of you farmers can start to understand more about what emissions actually are and what they mean for your farms. It's a conversation that's been going on for a long time, but it's hard, as I've kind of shown, to really grasp it, because we're talking about something we can't really see and it's hard to understand. So hopefully a tool like this, you know, it's better than a booklet that you have to read and try and figure out yourself. In this tool, you can actually put in the details of your own farm and understand each individual component and how it contributes to the whole. So we really tried to build a tool that was going to work for you, that was going to be simple, user-friendly, easy to access, something you're already familiar with if you've used AgroSuite before. And in particular, we really tried to focus on the science behind it to make sure that the numbers that we're giving you, while they're just an estimate, that they're the best estimate we can come up with, and that they're reliable, and that if you use other tools or other methods to do the estimation, that you're hopefully going to come up with very similar results. So I will talk just briefly about the methodology behind the tool. It may not be as interesting for some of you, but really just want to show the depth of work that we went to do this. So we started with the IPCC's international guidelines that Canada and many other nations use to account for and publish their emissions on a national scale every year. We also looked at numerous engineering guidelines, especially when we were talking about calculating energy use from barns and greenhouses and grain dryers. We did definitely look at the Canada's National Inventory Report, pulled out the soil specific factors, the specific livestock factors, and other considerations that are specific to Canada, specific to Ontario even, and tried to give the best assessment for Ontario that we could. And we also worked very closely with Agriculture and Agri-Food Canada's Holos tool and their Holos team, because Holos has already done this work. For those of you that have used Holos, it's a very detailed and powerful tool, but it can be quite overwhelming to use, especially if it's something that you haven't thought a great deal about before. So we tried to take AgriSuite and put it in terms that really an agricultural producer can use and understand and come up with quick estimates without sacrificing too much accuracy. So hopefully you'll see that in a moment when I show you what the tool actually looks like. Then we distilled it further down to Ontario. We pulled in regional weather data. So we've got weather data in here. It's 30-year average weather data. So obviously each year is different, but we do have weather data for every county in Ontario, every region. So you can choose the region or county that you're in and get, you know, a reasonably accurate estimate of what the weather has been like in that area for your farm. We consulted with different OMAFRA experts, industry experts, researchers to make sure that we were representing Ontario production practices properly. We had the best data in there. And we looked at literally hundreds of research papers, especially when trying to figure out which beneficial management practices to include and how they were going to impact emissions. We looked at other tools that were out there like Holos, like some of these other ones that maybe you've interacted with elsewhere in Canada or the United States, to really make sure that we were on the same page as everybody else, looking at the same beneficial management practices and trying to accomplish the same things. So we also had to draw a boundary on what we were looking at, and that boundary for us is really the farm gate. We're really trying to focus on the production practices and the things that a farmer has direct control over. So we're focused on crop production, mainly annual crop production, livestock and manure management, as well as farm structures that require a lot of heat. So barns for livestock, greenhouses for crops, and grain dryers for crop drying, obviously. The one place we go off farm a little bit is when we're looking at fuel emissions. So obviously on-farm fuel emissions like tractors and manure spreading in the field, those are accounted for. And then fertilizer production. So nitrogen fertilizer is a pretty energy intensive process to produce it. That obviously happens off farm. And when you as a farmer buy your fertilizer, it's already, the energy's already been used to produce it. But we did include that estimation for a couple of reasons. Number one, it's pretty straightforward. Like there's not a lot of difference in terms of the different sources of synthetic N. You get nitrogen, it's had to be produced using roughly this amount of energy. And also then we can compare it to manure, which is produced on farm. Obviously doesn't have the same fuel cost, but it has emissions in other cases. So that's why we have fertilizer production emissions included in here. And when we're calculating emissions, we're doing this on an annual basis. So we're not doing life cycle analysis. That's where you look at a particular product and you say, what are all the inputs that went into that product? What are all of the where's the whole value chain at? What does it take to get from, you know, very early production of that product to end use consumption? Well, you as a farmer have control over only a very small portion of that. So we didn't feel like that would be useful. We may get there at some point in the future. Often life cycle analyses are done for the purpose of understanding the total greenhouse gas impact of a particular product. And that wasn't our goal with this project. We're not even really looking at the greenhouse gas footprint of a farm because we're trying to show the impact of your production practices themselves. So we're looking at your farm as like as an operation. What are the operational changes? We're not looking at the one-time emissions of you, say, building your new barn or buying that tractor. We're saying how much are you using every year on an ongoing basis and what can you do to reduce that? And then when you use the tool, you'll see the results presented on this nice colorful little bar. You'll get a baseline result, which is your initial assessment. And then you can add management practices or BMPs or what we call mitigation practices in the tool. And you'll hopefully see that mitigation slider move towards the left, towards the green. There are some times that you might see it move towards the red. For example, if you currently are farming no-till and you decided to move to a full tillage rotation, you would probably see that slider move to the right. But hopefully you see it move to the left and you get a reduction. You can also click that button that says details and get a little bit more information. And I've got a bit of a walkthrough in a couple of minutes that I'll show you. I did just want to touch on the BMPs that we've included though. So we've got the tool set up in 3 modules: livestock, fields, and buildings. For livestock, we're primarily looking at feeding BMPs as well as manure. And I will go through the manure ones in more detail because this is Manure Monday. For fields, we're looking at fertilizer usage, as well as soil carbon and carbon sequestration. And then for buildings, we're primarily looking at heating energy, some electricity, but primarily heating energy use. So I'm just going to focus a bit more on each of these manure BMPs and show you kind of what's possible from an emissions reduction perspective. So let's talk about anaerobic digestion. This is, for those that don't know, this is where you take manure and also biomass and maybe food waste and some other, and anything with a lot of organic material in it, you feed it into a digester, and that digester is essentially a giant stomach. It produces biogas, which is like 30 to 50% methane maybe. And then you can refine that further into biomethane, which can actually be natural gas quality. You can put that straight into the pipeline. It also produces digestate, which is the byproduct. It's got a lot of the organic matter removed, but it's still a liquid that needs to be dealt with. And it does have some nutritional value, so you can put it on your land and things like that. Now, as far as AgriSuite goes, we're really not worried or dealing with these portions of it at the moment. What we're focused on is the livestock manure itself. We recognize that a lot of digesters use off-farm material. In fact, most of them do, to up their gas output. Hopefully in the future, we can include that. Right now, we're just looking at the livestock waste and what's the emissions reduction for that portion of the digester. And by putting livestock waste into your digester, you can pull out about 60% of the volatile solids, which is what produces the manure or produces the methane, pardon me. So you're getting rid of a lot of the methane. Now you can do more than that. It depends how long the material stays in your digester as to how long it has to actually get rid of all that methane. But on average, 60% is a really achievable outcome. And so from a greenhouse gas perspective, that's kind of the reduction we expect when you're doing an anaerobic digester. Separating your manure, whether it's the digestate after a digester or the manure before it goes in, that can be a good option. You're starting with a slurry manure that's got a bunch of solids in it. You put it through often a screw press, you press out the solid, and you end up with a liquid effluent as well. Now, a lot of the emissions here are going to be dependent on how much solids were in your slurry and how effective is your press at getting that out. Something with a little more slurry in it, like dairy manure, is going to be probably a little more effective at reducing emissions than, say, swine manure, which tends to be mostly liquid. So, we can achieve actually almost up to 50% reduction of methane when it comes to dairy manure. Swine is typically more like 15% reduction, but it still gets you a decent reduction, because when you pull out those solids, as you saw earlier on, solid manure releases a whole lot less methane than liquid manure. Liquid manure, especially stored anaerobically, that's really where those bacteria start to generate a lot of emissions. You can also cover your liquid manure with straw, and what the straw does is provides more space, again, for those aerobic bacteria, those oxygen-loving bacteria, to consume that methane. So by doing that with a nice thick layer of straw, you can get about 15% reduction in your emissions from that manure storage. Even emptying your manure storage more frequently. So we got the season of the year here: winter, spring, summer, fall. Hopefully it's obvious. And a lot of manure gets emptied in the fall, right? The problem with that is your manure has been full, your storage has been full or almost full through the peak of the summer, through the hottest months. And that hot temperature really drives those methane producing bacteria into overdrive. So you get a lot of emissions there. Just by emptying your manure tank before the summer, in the spring, or even emptying it kind of early to mid-summer before it's really gotten that warm in your tank. There's obviously a delay between atmospheric temperature and manure temperature. You can achieve about 25% less emissions just by emptying it at a different time. And then if you have the ability to empty it twice a year, not only have you basically kept it empty through the summer period, so there's not as much manure there to produce methane, you're also then emptying it again in the fall once those bacteria have really built up. You're emptying it again and getting them out, and you've got a much lower potential to produce methane over the winter. So you can get up to 40% reduction just by emptying it twice a year. Acidifying manure, that's a bit of a newer practice. It's shown a lot of benefit in terms of research. Manure is quite alkaline, pH of 8 to 12. to acidify the manure, we're actually looking for more like 5 to 6.5 as far as pH goes. So this requires adding quite a bit of acid. Usually sulfuric acid is what's been tested. And you can either add that in your transfer pit when it's, when it's going into the storage tank, or you can add it right to the storage tank. You've got a higher volume there, so it'll need more mixing. Either way, you're going to need a fair bit of acid. There's also been some work looking at acidifying the tank right after it's been emptied, so kind of inoculating it a bit, and that's shown some potential too. But really a huge potential here to reduce emissions. The methane reduction can be upwards of 40%. Some studies have shown as high as 80%. The practicality doing this on the farm, there's still some challenges there, but we are working on it. So there's a question in the chat about the digester and what happens to the organic matter when we're using a digester. Will we lose this organic matter in the soil over time? So that's a good question. We certainly are pulling out a lot of organic matter from the digestate. I might turn that question to Chris Brown. Chris, I don't know if you have other insight on that in the chat. If you want to respond to that in the chat, because I know you've done a bunch of work on soil carbon and digestate. So I don't want to say the wrong thing. I might direct you if you're able to respond to that too. I did want to touch just on solid manure. Most of what we've been talking about is liquid manure. Composting is a really good practice for solid manure because it lets you take the manure and you're inserting a bunch of oxygen. Again, we know that anaerobic digestion leads to a lot of methane. So stuffing oxygen in there helps reduce that methane. It drives the right kind of bugs. You get moisture, you get heat output. You also do still get gases. So you do have to be careful here, and it's trickier. So it's really hard to quantify both the methane reduction. You might actually get a nitrous oxide increase here because of the decomposition. So you have to be careful with compost, but if you're managing it well, you're stirring it well, depending on the type of livestock you're dealing with, this can be a good practice as well. So now I'm just going to show you a bit of a walkthrough. This is a pre-recorded video because it's more reliable than me doing it live. But when you go to the AgriSuite landing page, this is what you're going to see. All the tools are here. If you click on greenhouse gas, you can start a new calculation. And the first thing you'll come to is this general information page, and you'll see a table with lots of zeros. We haven't put any information in the tool yet, so these are our results, and you'll see these change ongoing if you come back to this as you're doing the calculations. But this is basically the reference point for the kinds of things that we're calculating. You can see the different types of gases there. You can also enter your own contact information here, and this is helpful for if you want to print out reports or save information. That way you and you want to submit it as part of a funding application or something like that, then you have your own information on there. Now you can rename your calculation, and I would recommend doing this if you do choose to sign in and create a profile. You don't have to sign in to use the tool, but it lets you save your work, come back to it later, and you can add multiple calculations. So in that case, you might want to rename it. There's 3 modules, as you can see at the top: livestock, fields, and buildings. I'm going to show you the livestock one just briefly here. Again, you can set the name for your system. And if you choose to sign in, you can have multiple systems, which is basically your barn and your manure system. You choose your location. It's all Ontario locations in there. I've chosen Wellington. It's nice and central. And then we move straight to adding livestock. So you can either add single livestock type or some preset combinations. I'm going to add dairy cows here, and I'm going to say that I've got a freestall barn. So that will help you estimate the different kinds of manure you're getting and the nutrients from that. If you're bedded on sand, you can select that, and it changes a few factors in the back end. But the most important one, obviously, is we need to know how many cows you actually have. So put that in. You can see on the right, we've estimated the amount of manure that we're producing at just about 2,800 cubic meters. You can change your milk production if you want to. There's a default in there, but that's an important factor from emissions because that helps us understand how much energy the cow is using. And then you want to tell us what your manure looks like. Is it liquid, solid, or are you pasturing the cattle at all? And you can adjust that. I'm going to leave it as liquid for now. I'm going to add a second livestock type, but you can also rename the livestock, and you might want to do that with multiple types because then on your reports, it'll be clear which is which. So I'm going to have my milkers and my heifers. So you can choose heifers in the selection here, the subtype. You can see it's pre-filled with some weights, but you can certainly adjust them to your own needs. And then I'm going to say I've got 50 heifers to match with my 100 dairy cows. Just numbers at this point, but you can certainly adjust to your farm. Then it's going to ask you for your storage is liquid and or solid. Basically, do you have a cover that's going to keep your rainfall out of it? That's important because that affects the volume of manure. And if you've got solid as well, we want to know what you're doing with the runoff. So here you can see our nice colored bar. For this system I've put in, it's about 1,170 tons of carbon dioxide every year. That's the ongoing emissions being produced from the cattle, from the manure management. If you click on the details button here, you'll be able to see the breakdown. So we've got, first of all, the energy, and that's really the manure spreading. Fuel use is what that is. We've got enteric emissions, and that is from livestock digestion. Our methane from manure is pretty much the same as the enteric, and then the storage nitrous oxide is a small component. You can also look at the individual animals. So you can look at the milking cows by themselves. You know, it looks like they're about 75% of the contribution, and then the heifers are about the other 25% of the 1,100. But the default and this chart always displays the total. Then you can choose the mitigation switch down here, and you can start to see the different practices. We've got the feeding practices, we've got the manure storage practices, and you can just basically choose different things, turn them on and off, and see what kind of difference it makes on your estimated emissions. There's also information buttons in some cases that help you understand for diet optimization. Basically, this is a list of practices that can help you optimize your diet better. Hopefully you're already doing that. So maybe you already have a well-optimized diet, and that means you're already 5% lower on your emissions than you would be with having, you know, the same diet for every animal on your farm. And again, you can click the details button and it will show you the difference you've made. So you've reduced your enteric emissions by 10%. No other category has changed. And so overall, you've reduced by about 5% your overall emissions. You can add other things, like let's add a diet additive here. You know, we go back, now we're 10% almost a reduction. You click on the details button. So we've reduced our enteric emissions by 20% by doing that. And overall, that's about 10%. Let's add some storage BMPs. We've got digestion, separators, all the ones we talked about. And you can, some of them are just a checkbox, some are a drop down that you have to select. But if we change our emptying tank, so we're liquid manure, let's empty it in spring and fall. Now we're at almost a 27% reduction. So it's made a big difference just by emptying our manure more often. We've dropped our methane emissions by almost 40%. And overall, that's 27% because we still have the other practices. Add a digester, now we're up to 40%. We've got, yeah, so our methane's down 70% overall. You can turn things on and off. I can turn the digester off. I can turn off the diet optimization, and you can see how different things influence. So it's really useful from that standpoint. You can try out different things and compare them. You can also produce a report, and this report will show you at a high level. There's a basic report, shows you at a high level what mitigation practices you've chosen, and also what your emissions are overall, your total, how much you're reducing, and then your net, the same table that we saw on the general information tab. If you've entered your contact information, it'll also show up at the top of this report here. I haven't, but that's where it would show up. There's also a more detailed report that, in addition to giving you that table, it shows you the individual livestock. It shows you the detailed report of your baseline emissions, the contribution of your different systems, and the detailed report for your mitigation. And then finally, we've got a tab with some resources. You can learn more about some of these practices. We're hopefully going to be adding more to this in the future. And there's contact information for myself, some of my colleagues. If you're going through the tool, you run into troubles or you're not sure what's going on, you can definitely reach out to us. So that's the basic walkthrough of the tool. And I know we're getting close to the end here, Chris. I will address your question in just a moment. I just wanted to kind of summarize by saying this tool really is intended to help farmers. It's intended to help you evaluate your current practices, to compare your emissions with conventional practices, to identify new BMPs and the potential reductions you can get from there, and even to maybe play around a bit and say, okay, what is it going to take for me to get to net zero? emissions? What will that look like for me someday? So I'm just going to jump straight to the end here because we're almost at time. If you want to access the tool, go here, take a snapshot of that QR code, or just remember ontario.ca/AgriSuite. Just Google AgriSuite and you'll get there. Wanted to say thanks very much and recognize that although climate change and emissions, they're hard to grasp and they're hard to understand, there really is a lot of value in us doing this work because we're here for the long haul. Our generations of our children and grandchildren are going to be here, and we want them to be able to still farm the land and be able to produce their own food. So I'll stop there. I'm going to throw up the QR code for the knowledge sharing event, and then I'll start to address some questions. So if you do need this QR code for the off-calf program, please feel free to snap a picture of that now, and we will turn it over to some questions. So I noticed Chris had one in the chat, and I'm going to address that now. That was in regards to, will intermittent aeration be added at some point in the future? So yeah, you'll notice that maybe there were some practices in there that maybe hopefully some of you maybe hadn't thought about implementing on your farm, but probably some that you had that weren't listed. And so definitely we are planning to continue to improve this tool in the future and add more practices like aeration. We tried to pick kind of the lowest hanging fruit at the outset and pick ones that we thought were going to provide good contributions for agriculture right now, but we definitely want this to be a living, breathing tool that will continue to be updated. We know that there's lots of research going on right now. The science is continually improving on a lot of this research. So we definitely have ongoing funding to make small updates to this tool over time, and then hopefully in another year or two, we'll probably do a bigger update and include a bunch of newer practices. So
That's
I'll
awesome,
turn it over
James.
to
Just a reminder, folks, that that QR code is not for getting a CCA credit. This is the one just for a KSE event. So Chris has put in the chat there, if you're looking for a CCA credit, it is offered. We just need your name and CEU number directly to Chris, or put it in the chat, and then we'll take care of that once we have the QR code ourselves. So just clear that is only for the KSE event. James, excellent presentation. Really like the way, even how you framed it in the beginning. Sometimes it's hard to get a perspective. We hear these big numbers. What does that look like? So now seeing that grain bin, I'm not going to forget that image of that's what a ton looks like. That was really helpful. I wondered, you were talking earlier about the different, you showed the farmstead, you showed the barn, the barnyard, and so on. Where do pastured or grazed animals fit into that perspective? Because we hear these huge numbers about livestock being pastured in, maybe it's Brazil or somewhere else, but I'm just curious where that fits into the equation as well.
So that's a great question. I didn't touch on pasture here. You can, in the tool, you can definitely set your livestock to pasture, and it's going to affect the emissions in a couple of ways. So first of all, when you pasture your livestock, especially in a cool climate like Ontario, the livestock will they'll actually produce a bit more enteric emissions because they need a bit more energy. They're taking in more feed because they have to produce more body heat and things like that to sustain themselves through the colder climate. Their metabolism is a little higher as a result. So you will see that play out a little bit in the emissions, but it will make a big difference as far as manure, because instead of storing that manure in a tank or a pile where you're going to get a lot of anaerobic bacteria, you're putting it right on the soil. It's going to decompose, and that fertilizer is going to go into the soil. So we do have those calculations in there. You will get a bit more runoff from manure put on pasture like that, because obviously rain and things like that. So all of those numbers are in there. I can't tell you off the top of my head what it would look like for that dairy farm right now to do that. But if you, when you're putting in your livestock, you can go in and you can set it, instead of 100% liquid manure, you can set it to 50% liquid, 50% pasture, and you'll see that in the emissions. We are hoping to add pasture as a BMP later on, so that down at the bottom you can say, okay, I want to increase my pasture percentage and be able to see that as a comparison. Unfortunately, right now, to do that, you got to go back up to the top and change your base livestock and see how it changes. But you can look at pasture from that perspective.
Perfect. I noticed on your one slide you were talking about the intention of this software, and the first intention was learn. And I know you mentioned for farmers to learn, but I know that it's also the perspective from you and your team that it's for you folks to learn as well. And so hoping that people will use this, try this on their farm, and if you come up with a glitch, you come up with something that's missed, you have a question, boy, that's helpful feedback to you and your team. Am I right on that, James?
100%, Andrew. Yeah, we definitely want feedback. We want to know what's working, what's not, especially if I didn't show you this, but if you use our buildings tool, you'll actually get an estimation of the amount of energy it's going to take for you to, say, heat your livestock barn. So if you've got swine or poultry and you've got a heated barn, I'd love to know, if you use that tool, how close is that estimate to your actual energy usage over the last few years? We've done some testing of it, but always looking for more data. So yeah, this really is an educational tool. The data is stored securely on our cloud. I mean, you don't even have to sign in to save it. You can just use it and forget about it later. But I'd encourage you to sign in, because then you can save it, come back to it later. It's stored as your inputs, so it's not as though, when you saw the inputs there, we're not asking for detailed information about your farm. You don't have to put in your contact info. The most we are asking for is the number of cows you have and where your farm is on a county basis. So it's really not not anything that the average person would be very concerned about putting in. We're not asking for detailed info, and so hopefully that give you some comfort level that this data is, there's nothing that could be scammed or anything here, anything like that. It's a very secure environment, and we don't have access to your data. It's all private. We can kind of track how many people are using the site, but that's about it. So
Okay.
it's not even that the data is useful for us. It's really useful for you.
And that maybe leads to one final question before we wrap up here, and that is thinking of the future. So if I put my farmer hat on, maybe the one concern is, hey, this is a great tool, I'd like to do this and so on, but does this mean that we're just gathering information now, so that down the road this is not going to be a voluntary thing, but this is something that I'm going to have to do and have to report on?
So that's a great question, Andrew, and I can definitely understand why there would be concerns about that. What I'll say at the moment is that this is a completely voluntary tool. It's not linked to anything. You can think of this kind of like an environmental farm plan. So those of you that have been through that process, yeah, I mean, we do ask you to do the environmental farm plan if you're going to be using the
various funding programs.
Yeah, the various funding programs. Sorry, I apologize for that blip in my memory there, but yeah, so we do ask you to do that, but it's intended for your use, not for ours. We're not keeping track of the environmental farm plans and saying, oh, well, you said this in your plan, but you didn't meet that objective. Even the federal government has said that, although, yes, they're focused on fertilizer emissions right now, their approach is voluntary. They're looking at encouraging adoption of best management practices, providing funding to do that. So I can certainly see a tool like this being used to support funding applications, perhaps being linked to future programming that whether we might have or other organizations might have. But because these estimates are so high level, I mean, our tool is not built to be a verification tool. So even if we wanted to, say, have everybody report on emissions, this wouldn't be the way that we would need to do it. So I hope that everyone is comfortable understanding that this is really about helping farmers and helping the ag industry learn and understand where emissions come from. And yeah, we do want you to adopt new practices, but this tool is here to help you. It's not here to make you do that. It's here to show you probably some of the things you were already thinking about, and how, now here's one other perspective from emissions instead of just erosion or something else that you can use to justify adopting some of these beneficial practices.
Perfect. Listen, thank you very much, James. That was an excellent presentation. That was a great way to kick off our Manure Monday season. And so we really appreciate that. Folks, just a reminder, we're back here next week. Next week is actually the virtual manure tour. So OPACA, which is the Ontario Professional Agri Contractors Association, along with Farm and Food Care, are going to be having an awesome discussion next week. It's not formal presentations. It's going to be an interactive panel looking at various aspects of manure management, new technologies and challenges, and how to get the most from manure. And so there's actually going to be 2 in-person meetings, and we're sort of piggybacking on that with a virtual tour as well. So it's going to be a great discussion. There'll be a panel there, and may go longer than the hour. We may go till 3:30 on that, just as we have all kinds of discussion around that. So look to see you next week. Thank you for joining us. The recording is there, and we'll hope to see you again next week. Cheers.